Hi Algebra 2 students, so today we're going to look at the ellipse again, but we're going to look at the ellipse shifted. So basically we're going to look at what if I move ellipses around today. So you're going to want your notes, writing utensil, and then also a calculator. So let's remember, how do we graph an ellipse? So the first thing that we always figured out is which way was our major axis. Was it vertical or horizontal? So we saw which one had the bigger denominator, which is the y. So this would be a vertical major axis, right? So basically my ellipse or my oval is going to go up and down. Your vertice then, remember, was the square root of this, so that would be 4. So since I'm going vertical, we have a center of 0, 0. I'm going to go up 4, put a dot, and down 4, put a dot. So my two vertices would be at 0, 4 and 0, negative 4. Your co-vertices then, we look over here, that would be 3, right? Because this is b squared. So I'm going to go 3 this way, 3 this way, and I now have my ellipse drawn. So my co-vertices were at negative 3, 0 and 3, 0. And then remember, to find our foci, we use this formula, b squared equals a squared minus c squared. So my b, we remember, is 3, because that's the distance of the co-vertice to the center. And then a was the vertices to the center, so that would be 4 squared. Oh, don't know c. So I got 9 equals 16 minus c squared. Subtract 16. I'm going to get 7, negative 7. So I'm going to get c squared equals 7. Square root both sides. So I'm going to get c equals the square root of 7. So if I go square root of 7, and the square root of 7 is approximately 2.6 roughly. 2.6. So I'm going to go 2.6 on both sides here. So my foci would be at 0, square root of 7, and 0, negative square root of 7 for both of them. Now, what if the ellipse moves? So originally we had this for our formula, right? Now, if the ellipse moves to a point HK, you would have this formula for the thing. Same thing for finding your vertices, your co-vertices, and all that. However, it's going to be a little bit more complicated to find the exact points for each of them. Let's just see a couple of examples. So, I got to graph my ellipse here. So I got x plus 2 squared over 16 plus y minus 2 squared over 36 equals 1. So very first thing I want to figure out is, what is my center? So my x value is going to be the opposite of positive 2, so it's going to be negative 2. And my y would be 2, because it's opposite of negative 2. So my center is at negative 2, 2. So on my graph, I'm going to put a little dot there, and I'm going to put a nice little C. So that way I know it's my center. Now, same thing counts. Bigger number under the y. So I am going to have a vertical ellipse again, okay? My vertices, that's going to be 6 away, but it's going to be 6 away from our center. So I'm going to count 6 up. 1, 2, 3, 4, 5, 6. Put a dot. That's one of my vertices. And then put 6 down. 1, 2, 3, 4, 5, 6. That's another one of my vertices. So my two vertices are at negative 2, 8 and negative 2, negative 4. My co-vertices then are 4 away, because remember this is b squared. So I'm going to be 1, 2, 3, 4 away. And 1, 2, 3, 4 away. So these are my co-vertices, CV. Draw in my ellipse here to the best of my ability. There we go. My two co-vertices are at negative 6, 2 and 2, 2. Foci, you're going to find them the same way. So it's going to be b squared equals a squared minus c squared. So my b is 1, 2, 3, 4, right? So this could be 4 squared. A squared, my a is 6, because that's the distance of the center to the vertice. So I got 16 equals 36 minus c squared. So subtract 36. I'm going to get negative 20 equals negative c squared, or c squared equals 20. Square root both sides. So I'm going to get c equals 2 square roots of 5, right? And the square root of 20, simplified, is going to be 4.47 in both directions from the center. So I'm going to go up 4.47, so, or about 4.5, right? So 1, 2, 3, 4. So about right there for one of my foci. And then 1, 2, 3, 4. About right there for my other one. Now, that's hard to actually write the exact distance. So what we're going to say, if for one of ours, our center was at negative 2, because right, it's still at negative 2, but to say how much it went up, we're going to say we went 2 plus 2 square roots of 5. So basically, our center, and we're going to go up 2 square roots of 5. Same thing to say we're going to go start at negative 2 for our x, and then we're going to go 2, but we're going to subtract 2 square roots of 5. Ultimately, that's what we did to find our 2 new foci points. Now, what if I want to find the equation of an ellipse that has a center that's not at 0, 0? So I have this ellipse here, and it has vertices at negative 2, 1 and negative 2, 9. And then I have some co-vertices at negative 4, 5 and 0, 5. So let's just kind of draw this out in our mind here. So I got negative 2, 1 and negative 2, 9. So I do know I'm going to have an ellipse that's kind of like negative 2, 9 and negative 2, 1. So it's going to look an ellipse that's doing one of these jobs, right? And then my co-vertices are going to be at negative 4, 5 and 0, 5. Now, I need to find the middle of this business. Well, it's the middle of the 2 vertices, right? And you can find the middle of 2 points by finding the midpoint. Do you remember how to find the midpoint? That is whatever your x's are added together divided by 2, and your 2 y's added together divided by 2. So let's find our midpoint between these 2 vertices, because the center's got to be in the middle, right? So I can find that. Let's call it C for center. So I'm going to go negative 2 plus negative 2 all over 2, and 1 plus 9 divided by 2. So my center is at negative 2, 5, right? Did I do my math right? Yeah. My center's at negative 2, 5. So I can start writing. Now notice this is an ellipse that is up and down. So I do know that my y squared is going to have a bigger denominator. So I'm going to have x plus 2, right? Squared over something, plus y minus 5 squared over something has to be equal to 1. Now, this is going to be our a, right? Which is the distance from the center to the vertice, and I know my center now is at negative 2, 5. So I know this distance right here, or the a distance, is 4, right? Because 5 and 9, that makes 4 for a distance. So underneath my x, or no, my y value, I'm going to have 4 squared, right? Underneath there. My x value then, this has got to be my b. Well, that's a distance of 2, so it's going to be 2 squared. So my actual ellipse has an equation of x plus 2 squared over 4 plus y minus 5 squared over 16 is equal to 1. Sometimes I feel this little graph here, or the little sketch of him, really does help me figure out where is what and who is who. let's try another example here. So I have my vertices and I have some foci on this one. So let's graph here. I got my vertices of -3, 4, and 5, 4. So it looks like I'm changing my x values, right? So I got 1 at -3, 4, and 1 at 5, 4. And I got some co-vertices. I don't know about them though, but let's just draw them in. And then I got some foci and -1, 4 and 3, 4. Well, we need to find the center. So let's find the center based on our midpoint formula. So I'm going to find the center from the foci because the foci still have the same distance, right? I'm going to ultimately, center has to be in the middle of the vertices and the foci. So let's do the foci because I got to do with smaller numbers. So -1 plus 3 over 2 and 4 plus 4 all over 2. So my center is at -1, 4, right? -1, 4. No, +1. Whoopsies, +1. Okay, so I now have the beginning of my equation, x minus 1 squared over something plus y minus 4 squared over something. Whoop, there shouldn't be a 1 there. That was my something. There we go. Equals 1. Let's find the distance of everything here. So I do know my x distance, or my center to my vertices, is 4, right? So I do know I'm going to have 4 squared under the x. I need to find this, though. I need to find my co-vertices. So we can use our really cool formula. B squared equals a squared minus c squared. So b, we don't know b, though, because that's the co-vertices. But I do know my a value is 4. And our foci, they're a distance of 2, right? Because I got 1, 4, and 3, 4. 3, 4 is one of my foci. So they are a distance of 2 away from my center. So 16 minus 4, or 12. So b equals the square root of 12, which is the same thing as 2 square roots of 3. So I'm going to have 2 square roots of 3 squared on the bottom there, which x minus 1 squared, let's just write this out nice. So 4 squared is 16, y minus 4 squared over, well, square root of 12 ultimately is what we did, right? So this would be just 12 underneath, and that would be my final answer. X minus 1 squared over 16 plus y minus 4 squared over 12 equals 1. And that's the end of this video. See you later, Sabers.